My name is Dr. Steve. I am a professor here at NKU, Northern Kentucky University. And today what we will be showing you is a demonstration that has to do with zinc and the formation of zinc chloride. So what actually occurs in this demonstration is two steps. The first thing that we're doing is we have solid zinc, and that's what the S after the symbol means. It means that it's in the solid form. So this really is just zinc metal. So we've got pieces of zinc metal, and then HCl, which is aqueous. Now you may not be familiar with it, but the aqueous label, AQ, means dissolved in water. So anytime you see this AQ, whatever is before it in the chemical symbol is dissolved in water. So in this case, we have HCl dissolved in water. So what that means basically is it's diluted HCl and not pure HCl, basically. So the zinc solid is being added to HCl, and that's again in water, and a chemical reaction is occurring there. And in this chemical reaction, we're forming zinc chloride, ZnCl2, and that is actually a solid. Now you're not going to see it as a solid because very quickly something else happens, but the zinc chloride itself is a solid, and will also be forming H2 gas that comes off. When you react an acid with a metal, quite often you get H2 gas released as a product. As I said, you're not seeing this solid because immediately once that forms, a physical change occurs as well. And that physical change is from your zinc chloride, from your solid, to an aqueous form. So it's being dissolved in water. Zinc chloride is soluble in water, and because it's soluble in water, it immediately goes from the solid, as soon as it's formed, to the aqueous form. So therefore, you won't see the white powder that forms itself. It will be dissolved in your water, and you'll just look like normal water. Okay. So what we're doing here is we're going to show the actual reaction as it occurs. And the first thing that we've done is we've measured out HCl and put it inside the beaker, and that is sitting on top of a hot plate. So we'll go ahead and turn on the hot plate to start heating the HCl. Now, one thing you have to be very aware of with HCl is it has a boiling point of about 100 degrees. So once you heat it up basically to boiling water or 100 degrees, it will start to vaporize. That gas is dangerous, and because of that, we have a fume hood over top of our beaker, and that will capture the gas and allow to safely remove it from the environment. So we'll turn on the fume hood, and now that we're heating it, we're going to let it heat up briefly, and we'll continue on. Now that our hydrochloric acid has heated up some, we're going to go ahead and add the zinc to it. So we'll drop in a couple pieces of zinc, and if you look closely, you can see the bubbles starting to rise off of the zinc, and that is that chemical reaction occurring. So those bubbles are the hydrogen gas being released, and at the same time that that occurs, the zinc is reacting with the chlorine in the solution and actually forming our zinc chloride. So those bubbles are your sign of a chemical reaction occurring. Now that the reaction has occurred for a while, the zinc metal has all but disappeared at this point. So there's just a couple little pieces of zinc yet to react. And then after the zinc has all reacted, we will boil off the aqueous solution, so the water and the hydrochloric acid, to recover the zinc chloride, which is currently dissolved in the water. Now that we're heating the solution more vigorously, we can see gas coming off the top, which is the water vapors and HCl vapors as they're boiling. To show that it is HCl coming off and is acidic, we can use litmus paper and hold the litmus paper over it to react with the vapors. Litmus paper, or at least blue litmus paper, starts out as blue, and then as it reacts with an acid, which is what HCl is, it's going to turn to a reddish color. So here you may be able to see on the cameras, I'll move it closer so you can see in a second. The blue litmus is actually turned into a pinkish red as it reacts with the HCl gas to show that it is an acidic solution that's being boiled off here. So it's kind of hard to see there. So here is the litmus shown with another piece of litmus paper. The paper that is on the right is the unreacted litmus, and the paper on the left is the litmus that has been exposed to the vapor of the solution, or the HCl being boiled off. So you can see that the litmus that has been exposed to the vapor is much more red than the original blue litmus paper. Now that most of our solution has boiled off, two things can be seen here. First, there's a little bit of a yellowish color, and that is reminiscent of HCl in a more concentrated form. And the second thing is, at this point, because it's largely HCl left over, the vapor that's coming off is mostly hydrochloric acid. And you can see the difference now when we place the litmus paper above it. Before, when it was a slow gradual change to pink, now just setting it there, you can very, very quickly see it actually change. We're getting to the point now where almost all of the liquid has evaporated. So all of the water and the hydrochloric acid has been boiled out of our beaker. And in a few moments, we should start seeing the solid form that is the zinc chloride on the sides of the beaker, which will show us that the solid is returning. In the video, it's hard to see, but we can see from the outside that the solid is starting to form now as the last of the liquid is being evaporated off. So very quickly, there's a little liquid left, but just to show you the solid that's forming here, if you look inside, you can see a ring of solid throughout the bottom. And put it back on, take off the rest of the liquid to finish evaporating that off, leaving only the solid zinc chloride behind. Now that all the liquid has been evaporated, only the solid zinc chloride is left behind. This solid zinc chloride can then be collected and tested in terms of solubility to see if it is soluble in water or not soluble in water.